Welcome to aminacademy.com. In physics, let us discuss about mean free path. Molecules in a gas have rather large speeds of the order of the speed of sound. A gas leaking from a cylinder in a kitchen takes considerable time to diffuse to the other corners to the room. Normally, we can experience this. The top of a cloud of smoke holds together for hours. This happens because the molecule in a gas have a finite though small size, so they are bound to undergo collision. As a result, they cannot move straight unhindered. Their paths keep getting incessantly deflected. Suppose the molecules of a gas are spheres of diameter d. Focus on a single molecule with the average speed v. It will suffer a collision with any molecules that comes within a distance d between the centers in time delta t. It sweeps a volume pi d square, that is area, cross area, pi d square v dt, wherein any other molecules will collide with it. In physics, mean free path is the average distance over which a moving particle such as an atom, a molecule or photon travels before substantially changing its direction or energy or in a specific context. Other properties. Typically as a result of one or more successively collision with other particles. Mean free path we'll discuss further. A gas molecule's mean free path lambda is its average path length between a collision. Mathematically, the mean free path can be represented as follows: lambda equal 1 over root 2 pi d squared into n over v. Let's look at the motion of a gas molecules inside an ideal gas. A typical molecules inside an ideal gas will abruptly change in its direction and speed as it collides elastically with the other molecules of the gas, some gas. Though between the collisions, the molecules will move in a straight line at some constant speed. This is applicable for all the molecules in the gas. It is difficult to measure and describe this random motion of a gas molecules. Look at this figure. The random path followed by a gas molecules. Look at this randomly goes straight line and moving, it's changing its direction like this random motion. As its name says, lambda is an average distance traveled by any molecule. Between collisions, we expect lambda to vary inversely with n over v, which is the number of molecules per unit volume or the density of molecules between. This is n over v is the density of molecules. Between it, there are more molecules, more are the chances of them colliding with each other, hence reducing the mean free path. Suppose the gas is more denser, that is more molecules in the container, then mean free path length become reduced. And also lambda would be inversely proportional to the diameter of the molecules. If more diameter molecules, that lambda is less, free path length is less, because if the molecules were point masses, then they would never collide with each other. Thus, larger of molecule, smaller the mean free path. Larger the molecules, smaller the free path. It should be proportional to pi times the diameter square, that is pi d square, and not the diameter itself, because we consider the circular cross section and not to the diameter of itself. So far we discussed about mean free path of a gas molecules. We have done. Please subscribe our YouTube channel.